Betelgeuse or Jewish insect, a red monster star on the verge. Betelgeuse, a red monster star, is an interstellar wonder. Assuming you placed it where the Sun is, it would extend all the way to Jupiter's orbit. Completely temperamental, it is preparing for a massive detonation. Betelgeuse's red scale has never been seen before. This Goliath star, on the edge of our cosmic system, is conveying startling messages through space. Cosmologists have tracked down something incredibly unsettling about this enormous object. The famed James Webb Space Telescope and researcher Brian Cox have provided a stern warning regarding the possibility of witnessing a cosmic explosion that could forever alter the night sky. The riddle of Betelgeuse. In the vastness of the universe, stars are born, live, and die in astounding ways. One particular star has recently captured the attention and concern of both space experts and the general public. Betelgeuse, an incredibly massive red star in the constellation Orion. It is monstrously large and ancient. Its unique, shifting, and rosy splendor has always captivated astronomers, but recent events have sparked renewed interest in this enormous celestial body. As we learn more about Betelgeuse, we find ourselves on the brink of a potentially significant moment in its history. But what could these changes in Betelgeuse mean? Are we about to witness a grand display of cosmic fireworks? The scale and life cycle of Betelgeuse. Betelgeuse is a heavenly giant, roughly 1,000 times larger than our Sun, almost beyond human comprehension. Imagine a star so massive that, if it replaced the Sun, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars entirely. This enormous size not only highlights the sheer grandeur of Betelgeuse but also indicates its stage in the stellar life cycle. As a red supergiant, Betelgeuse is nearing the final phase of its evolution. After depleting the hydrogen in its core, helium has taken over as the primary fuel for its fusion processes. This star is estimated to be between 8.5 to 10 million years old. While relatively young by cosmic standards, it is ancient compared to human history. Over millions of years, Betelgeuse has undergone dramatic transformations, evolving from a bright blue star into the red giant we see today. Why is Betelgeuse red? Betelgeuse's appearance changes due to the ongoing battle between gravity and nuclear fusion. One of its most distinctive traits is its deep red hue. This color results from its cooler surface temperature compared to hotter stars like our Sun. For context, the Sun's surface temperature is around 5,500 Kelvin. Betelgeuse's surface temperature is only about 3,500 Kelvin, making it cooler and giving it its reddish glow. However, this color shift is more than just a visual feature. It provides crucial insights into the star's physical condition and internal processes. Interestingly, historical records from ancient Rome and China suggest that Betelgeuse was yellow just 1,000 years ago. By the 9th century, Arab astronomers noted its red color. This historical shift isn't just a fascinating observation, it signals an ongoing evolution in the star's life cycle. The Great Dimming Event. Another intriguing aspect of Betelgeuse is its fluctuating brightness. It is a semi-regular variable star, meaning its brightness changes periodically. It typically follows a multi-day cycle and a longer 5-year cycle. In 1836, astronomer Sir John Herschel recorded these cycles. However, what makes Betelgeuse truly strange is its unexpected and unpredictable dimming events. Unlike many variable stars that follow a predictable pattern, Betelgeuse occasionally deviates from this rhythm, suggesting complex and less understood processes occurring within its massive structure. One of the most dramatic instances of this occurred in late 2019. The event, now known as the Great Dimming, left astronomers stunned. Betelgeuse, one of the brightest and most recognizable stars in Orion, mysteriously lost brightness at an alarming rate. By February 2020, it had dimmed to the lowest brightness ever recorded. The dimming was so severe that naked-eye observers noticed the difference, even in areas with heavy light pollution. This sudden drop in brightness led to widespread speculation. Was this a sign that Betelgeuse was about to go supernova? Understanding the cause, mass ejections and star evolution. Studying Betelgeuse is complicated by the time delay of light. When we observe Betelgeuse today, we are actually seeing it as it was about 725 years ago due to the time it takes for light to reach Earth. To better understand its behavior, scientists, including Andrea Dupree, a senior astronomer at Harvard Smithsonian Center for Astrophysics, closely monitored Betelgeuse using the Hubble Space Telescope. Hubble's ultraviolet observations revealed that Betelgeuse had undergone a massive mass ejection, expelling hot, dense material into space. This material traveled at speeds of 200,000 miles per hour and eventually cooled into dust, which temporarily obscured the star's light, explaining the Great Dimming. What's next for Betelgeuse? While Betelgeuse is not expected to explode imminently, its unpredictable behavior has scientists on high alert. A supernova from Betelgeuse would be an unprecedented cosmic event, bright enough to outshine the full moon and remain visible in the daytime sky for weeks or even months. However, predictions remain uncertain due to the star's complex nature. The only certainty is that Betelgeuse is a star in transition, and whether it erupts tomorrow or in 100,000 years, it remains one of the most fascinating objects in the cosmos. Could Betelgeuse go supernova soon? The question that astronomers and the general public alike are asking is, when will Betelgeuse explode? While we know that Betelgeuse is a dying red supergiant, predicting the exact timing of a supernova is incredibly difficult. Current estimates suggest that the explosion could happen within the next 100,000 years, which is an instant in cosmic terms, but a long time from a human perspective. However, some recent anomalies have led to speculation that the event could occur sooner than expected. The Great Dimming of 2019 to 2020 was one of the most dramatic and unexpected events in Betelgeuse's recent history. A second dimming event was observed in 2023, raising concerns that the star might be experiencing rapid internal changes. Observations from the James Webb Space Telescope suggest that Betelgeuse may be undergoing significant mass loss, a potential precursor to a supernova event. What happens when Betelgeuse explodes? When Betelgeuse finally goes supernova, the explosion will be one of the most spectacular cosmic events ever witnessed by humans. Here's what we can expect. 1. A blinding flash of light. Betelgeuse will suddenly brighten to an extreme degree, possibly shining as bright as the full moon in the night sky. The explosion will be visible even in broad daylight for several weeks. At night, it will cast shadows on Earth, something only the moon has ever done. 2. A rapidly expanding shockwave. The explosion will send out a tremendous shockwave, traveling at speeds of millions of miles per hour. This blast will obliterate any planets or celestial objects near Betelgeuse. Fortunately, Betelgeuse is about 640 light-years away, so Earth will be safe from direct effects. 3. A supernova remnant. After the explosion, Betelgeuse will leave behind either a neutron star, a acidic, ultra-dense core left after the outer layers explode, or possibly a black hole, if Betelgeuse is massive enough. The debris from the explosion will spread out into space, enriching the interstellar medium with heavy elements like carbon, oxygen, and iron, materials necessary for the formation of new planets, moons, and even life. Will Earth be affected? Since Betelgeuse is relatively close, some people have speculated that its supernova could have negative effects on Earth. However, astronomers assure us that the explosion won't harm life on Earth. A supernova needs to be within 50 light-years to cause serious damage, and Betelgeuse is more than 12 times that distance. We won't experience any dangerous radiation. While supernovae release gamma rays, Betelgeuse is not the type of star likely to produce a deadly gamma-ray burst aimed at Earth. We will see an incredible cosmic spectacle. The night sky will be dramatically altered for months, possibly years. Scientific significance of Betelgeuse's supernova. If Betelgeuse explodes in our lifetime, it will be the closest supernova ever recorded in modern history. This would provide a rare opportunity to study a supernova in real time. Past supernovae have occurred much farther away, making detailed observations difficult. New insights into stellar evolution. Scientists will be able to analyze the explosion's aftermath with powerful telescopes like James Webb and Hubble. An improved understanding of the universe's chemical makeup. The supernova will scatter heavy elements, contributing to the birth of new star systems. A cosmic clock is ticking. Betelgeuse remains one of the most fascinating time bombs in the universe. It is in its final phase, and while we don't know exactly when it will explode, one thing is certain: when it does, it will be a once-in-a-lifetime celestial event. Until then, astronomers will continue to monitor this red monster star, waiting for the moment when it finally erupts in a dazzling supernova that will change the night sky forever. The cloud of dust that made the star look dim during the eruption's 3 months was more significant than expected. According to Dupree and her team, about twice as much material as anticipated was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly noteworthy because it occurred at a much faster rate than the Sun's. Astronomers were unsure whether this indicated an approaching supernova due to the magnitude of the mass ejection and the subsequent dimming, which was observed at a distance of approximately 725 light-years from Earth. This uncertainty adds to the suspense, as a blast of this kind could be visible from Earth and provide an exciting opportunity to study supernova theories up close. But the question remains, what implications does this darkening have for Betelgeuse's future? Is it a sign of an imminent supernova, or is it a one-time occurrence in the star's complex life cycle? Multiple theories have been proposed to explain this rapid transformation. One popular theory suggests that this was an early stage in the supernova process, reinforcing the idea that Betelgeuse is nearing the end of its life. Another theory proposes that dust, possibly from the star itself, was obstructing our view. It is well established that Betelgeuse and other red supergiants release materials that can accumulate into a thick cloud of dust, enough to obscure the star's light. A third theory examines how changes in the star's apparent outer layer, the photosphere, could affect its brightness. A combination of observational methods, in-depth analysis, and spectroscopic investigations demonstrated that Betelgeuse's actual temperature had decreased. This suggests that the dimming could have been caused by a large dark spot on the star's surface. Observations indicate that Betelgeuse lost at least 170 degrees Fahrenheit, about 94 degrees Celsius, around the time its brightness began to fade. The role of the Hubble Space Telescope was crucial in understanding this phenomenon. Hubble, humanity's sentinel in space, helped astronomers determine that Betelgeuse's dimming was likely caused by a large amount of hot material ejected into space. This material formed a cloud of dust that partially covered the star's surface, reducing the amount of light reaching Earth. It was thought that the dust cloud consisted of extremely hot plasma emitted by a large convection cell. This plasma traveled through Betelgeuse's hot atmosphere to its colder outer layers, where it condensed into dust grains that blocked light from about a quarter of the star's surface. The impact of the ejected material was confirmed by Hubble's ultraviolet spectroscopic observations, which began in January 2019. These observations played a key role in reconstructing the sequence of events leading up to Betelgeuse's dimming. Ground-based telescopes also detected a decrease in brightness as early as December 2019. Hubble's data further confirmed these findings and provided deeper insights into the ejected material. The realization that Betelgeuse was losing material at a much faster rate than previously thought has profound implications for our understanding of stellar evolution, particularly in red supergiants. However, Betelgeuse is not the only star to undergo such dramatic changes. Historical supernovae, such as SN 1054 and SN 1987A, have provided significant insights into the final stages of massive stars and the formation of new elements. For example, SN 1987A, which occurred in a neighboring galaxy, allowed astronomers to observe a supernova explosion and its aftermath up close. Such supernovae contribute to the galactic cycle by dispersing heavy elements and influencing future star formation. If Betelgeuse eventually explodes as a supernova, it would create a spectacular light show visible from Earth. The explosion would be brighter than the Moon and possibly visible even during the day. Such an event would provide an unprecedented opportunity to study the final stages of a massive star's life, the formation of cosmic structures, and the distribution of heavy elements across the universe. Despite the dramatic nature of a supernova, Betelgeuse's distance from Earth ensures that such a blast would not pose any direct danger to our planet. Ultimately, the insights gained from studying Betelgeuse's transformation will continue to advance our understanding of stellar evolution and the role of red supergiants in cosmic expansion. These massive stars symbolize the final stages of a star's life cycle before undergoing a supernova explosion. Their enormous size and relatively short lifespans make them ideal subjects for studying the processes that lead to their explosive deaths. The energy released during their final stages contributes to the formation of heavy elements essential for planetary formation and even life itself. The study of Betelgeuse's transformation is not just about understanding one star, it has broader implications for astrophysics and the life cycle of massive stars. Red supergiants like Betelgeuse play a crucial role in the cosmic ecosystem by enriching their surroundings with heavy elements through stellar winds and eventual supernova explosions. These elements, such as carbon, oxygen, and iron, are essential building blocks for planets and life. If Betelgeuse does explode as a supernova, astronomers will have a rare opportunity to observe the process in real time. Modern telescopes, including space-based observatories like Hubble, the James Webb Space Telescope, and upcoming next-generation instruments, will allow scientists to capture unprecedented details of the explosion. This would help refine supernova models, improve our understanding of the physics behind stellar death, and provide new insights into the formation of neutron stars or black holes. In addition to direct observations, supernova remnants from Betelgeuse could provide further clues about its final moments. When a massive star explodes, it leaves behind either a neutron star or a black hole, depending on its mass. Given Betelgeuse's estimated mass of about 10 to 20 times that of the Sun, it is likely to produce a neutron star rather than a black hole. The explosion would also send shock waves through space, interacting with surrounding interstellar material and contributing to the ongoing cycle of star formation. Despite its advanced age and irregular behavior, Betelgeuse's ultimate fate remains uncertain. Some models suggest it could still have thousands, or even millions, of years before going supernova. Others argue that the recent mass ejection and dimming may indicate that the end is closer than previously thought. Astronomers continue to monitor the star closely, looking for signs of additional instability, such as changes in brightness, increased mass loss, or unusual spectral signatures. The importance of Betelgeuse extends beyond scientific curiosity. Throughout history, bright stars like Betelgeuse have played significant roles in mythology, navigation, and cultural traditions. As one of the most recognizable stars in the night sky, Betelgeuse's potential explosion would be a once-in-a-lifetime event, captivating both scientists and the general public. Whether Betelgeuse explodes within our lifetime or remains stable for centuries to come, its study will continue to deepen our understanding of stellar evolution and the complex mechanisms driving the universe's most powerful events. As technology advances and observational techniques improve, future discoveries about Betelgeuse and other red supergiants will shed new light on the birth, life, and death of stars, offering a glimpse into the cosmic forces that shape our universe.